Good afternoon, ladies and gentlemen. It is my honor to make a presentation for you today. My topic is novel decellularization of cartilage matrix by using a combined chemical, physical, and enzymatic process. I am Lishan, come from Taipei, in Municipal Lishan High School. Cartilage is a flexible connective tissue in the human bodies. In Japanese, it's called nankozu, and there are a lot of difficulties for repairing cartilage. One of the best ways is to use tissue engineering. So we may need some stem cells, growth factor, cartilage cells, and a scaffold. Scaffold is a temporary structure for the cells to grow. And after the invasion culture, implantation it into human body and the tissue formation. In traditional methods to repair the cartilage, it is often used cell transplantation. But most of the time, the degree of the cartilage defect is too large to operate. So the idea of the decellularization comes out. Decellular means remove the cell nucleus in the tissue. This is the model of the cartilage tissue. Cartilage matrix is a structure in the cartilage tissue after removal of the cell nucleus. And the matrix was reported that be closely associated with the stem cell differentiation. It means if we put the stem cells in the cartilage matrix, and the matrix will cause the stem cells turn into the cartilage cells. And we only want to protect the matrix, not the cell nucleus. So the more DNA removed and the more matrix contents preserved, the matrix quality better. In traditional methods of the decellularization, at first, physical method is to use crystal cycles. It is to use the ice crystal to destroy the cell. And SDS is as the detergent. DNase, RNase are used to hydrolyze the DNA and RNA to assist the process. Also, chemical methods and enzymatic methods should do cycles several times to obtain the better quality of the matrix. Here, we will present a novel decellularization process of cartilage matrix. The novelty in this process is the combination of the chemical methods with physical methods and enzymatic methods. We have three differences from the traditional methods. First, we additionally ground the tissue into powder. Two, we use tritone X100 as the detergent to replace SDS. Third, the process didn't need to do a cycle and it can have the better quality of the matrix. At first, the cartilage is from a piece, and we cut it into pieces. Add the liquid nitrogen to make them brittle. Then grind them into powder, and use mesh to separate the matrix into small size and the large size. The second part is decellularization. We add all of these chemical and enzyme to the decellularization. Because all of these chemical and enzyme may disrupt the cell's growth, so we need to do the washing steps by buffer solution. This is the decellularized porcelain cartilage matrix we made. The particle size is, for small size, is 0.025 to 1/4 millimeter. The large size particle size is 1/4 to 1/2 millimeter. We want to observe the cell nucleus under the fluorescent microscope. And we use the fluorescent dyes to stain DNA. Before the process, in this picture, there are many spots. It means cell nucleus. And After the decellularization process, we can observe any spots in the matrix. So we can infer that this process can remove the cell nucleus completely. The DNA presents acid. In this chart, blue line is small size, we made, and the yellow line is large size. ECM is no decellularization matrix as the control group. In the small size and the large size, we all remove over 98% of the DNA. And it means although the cartilage is from pigs, but we can remove the pig's DNA. We only preserve the matrix, not the cell nucleus. So it can act as a human natural matrix. Gex acid. Gex is a specific component in the matrix. It means if we preserve more gex in the matrix, the effect on the matrix is mild, and the quality of the matrix is the best. In small size and the large size, we preserve 45% in the small size and 55% in the yellow size. From doing the DNA assay and Gex assay, we can ensure the efficiency of the cartilage matrix quality. This two line is the traditional methods by SDS as detergent. In cycle 1, the DNA removal rate is 52% and the Gex preservation rate is 68%. Although the preservation rate is high, but there were a lot of pig's DNA in the matrix. So they do more cycle. Until the cycle 6, the DNA removal rate is achieved 99%, but there were only 9% of the Gex preservation rate in it. Compared to our process, we use Triton X100 as a detergent. We only do one cycle, and the DNA removal rate can be 99% and preserve more Gex contents in the matrix. Because SDS is an ionic surfactant, it is very effective for removal contents in the matrix. When it removes the DNA, it will also remove the contents in the matrix. And Triton X100 is a non-ionic surfactant. It can protect the cartilage matrix well, but it has a deadly disadvantage. It can't remove DNA well. So we add the grinder. Grinder is to increase the surface of the matrix, and it can help Triton X100 to remove the DNA. So in this research, we can say Triton X100 and grinder can better than SDS. And Triton X100 is a much better detergent than SDS, and only one decellularization cycle is necessary. Because all of the chemical and enzyme may destroy the cell's growth, so we need to do the washing process, and we need to do a cytotoxicity assay. This blue line means the Triton X1, culture the cells in the Triton X100. Because Triton X100 may kill a cell, so it can be as a negative control group. And FBS medium is a general medium for the cell's growth and can be a positive control group. The red line is large size, green line is small size. CCK8 is to analyze the cell growth. From analyze day 1 to day 3, in the negative control group, the cell didn't grow. And there are no difference between the general control, positive control group and we made large size and small size. LDH is to test the cellular death amount. from analyze day 1 to day 3. In the negative control group, there are huge amounts of cellular deaths in Triton X100. And there are no difference between the positive control group and the large size and small size. From doing LDH assay and CCK assay, we can ensure the security of the matrix and to prove the washing steps actually works in this process. So the conclusion, here, in this research, the novel cartilage matrix decellularization process was developed. And this process has 3 advantages. First, it saves a lot of time and be more convenient than traditional process. 2, it is more efficient in DNA removal rate, and it can preserve more GX content. Third, the matrix didn't have the cell cytotoxicity. And this is the protein complex. On its surface, it contains with the matrix we made. It can be a scaffold model. We hope that human stem cells can culture in it, and the matrix will cause stem cells turn into cartilage cells. It can be a new concept of cartilage repair for us. And in the future, we hope this novel process can be a technique for repairing cartilage. Thank you for listening.
ありがとうございました。それでは何かご質問などございましたら、どうぞ挙手の方お願いいたします。ご質問などいかがでしょうか。はい、こちらの方の方にお願いします。
Hello. Amazing presentation, by the way. I understood everything, so that's awesome. But I have a question. So, in relation to more traditional methods, how expensive is this process?
The cartilage is from the pigs, but bought in the market, it is cheap. And the Triton X100 didn't cost too much money too.
But in relation to using it, with the whole process of the enzymatic methods, was everything together less cost than traditional methods? If we would use this in the future?
Sorry.
So, excuse me, the Triton X100 in relation to the SDS traditional method, if used with human tissue, would it be less cost, or would there be less cost involved?
Cost?
Hey.
No. It's cheap.
It's cheap, okay. Thank you.
ありがとうございます。その他ご質問などございましたら、よろしくお願いいたします。ご質問の方はよろしいですか。はい、ではマイクをお持ちいたします。
Thank you for nice talk. And just a question. So in your process, so you divided your sample into 2 classes, which depending on the size, before you're adding some chemicals and enzymes. Okay, small particles and large particles. So my second question is, how did you determine the size?
We use mesh.
No, I mean okay, so how did you determine the mesh size? The small and large.
Yeah. The
So borderline, you can choose the borderline by yourself.
we can put the matrix on the mesh, and mesh can divide into
Yes, so what type of mesh you use depends on your choice.
Sorry.
You can choose the mesh size.
Yes, I can choose the mesh size.
So why did you choose this size?
Why? Because after the grind the cartilage into powder. The size is almost 1 cup in a meter. So we use mesh to divide it into small size and large size, and also can test in the small size and large size to the process efficiency.
ありがとうございます。よろしいでしょうか。それではお時間も終わりましたのですので、以上とさせていただきます。ヤン・イーシュアンさんでした。ありがとう